Hello class 8 students, welcome to the e-learning classes of chemistry. So today we'll discuss the first chapter of chemistry, that is matter. Okay, and today's point of interest will be change of state of matter, latent heat, phase change diagram and 5 states of matter. Clear? So what is matter? The basics of matter you have already learned in the previous classes. So we are not going to discuss those things. Let's discuss something new, which is new to you. Clear? Now, tell me, when you heat any body, any substance, what happens? You know that it is changing its state. It changes its state. Isn't it? Clear? Now, why there is a change in state? Because you give heat, means it is absorbing energy, and thereby it is changing the state. Clear? Now, this changing of state in chemistry, we call it phase. Change of state, we call it phase. Clear? Let's take solid is a phase. Solid phase, we call it solid phase. Liquid is a phase. Gas is a phase. Clear? So change of state. State means phase. Got it? Now, let us understand what is happening inside a substance that it changes from solid to liquid. Quickly, look over here. There's a flowchart of this. When you heat in substance, it absorbs heat energy. Clear? When it absorbs heat energy, the molecules are absorbing the heat energy and thereby the kinetic energy increasing. Okay, the molecule's kinetic energy increases. And thereby, as kinetic energy increases, it moves vigorously. It goes far apart. Intermolecular space increases. Intermolecular force decreases. So intermolecular force decreases and thereby intermolecular space increases. Clear? Now, you should know what are phase change. There are basically two types. One is endothermic, one is exothermic. Like over here, you have giving heat. Means what? The substance is taking heat. Isn't it? Means what? It is absorbing heat. So absorption of heat is called to be endothermic. Endo means absorption. Clear? Whereas exothermic means liberation of heat. Exothermic means liberation of heat. Means heat is giving out from the body. Understood? Now, you should know the term, a new term to you, that is latent heat. Okay? What is this latent heat? This latent heat is that heat when you supply to a substance for the substance to change its phase from one phase to another phase. Like, suppose you're heating any water in any container. Clear? Now, you are measuring the heat that it is increasing. Say, you are seeing the temperature that is say 20 degree, 30 degree, 40 degree, 50 degree, 70 degree, 80 degree, 90 degree, 99 degree, and then 100 degree, it stops. It does not rise fast. After that, it does not rise. Why? Because you can see that after 100 degrees Celsius, what happens? The water changes its phase from liquid phase to gaseous phase. Clear? So at this point, the temperature is constant, but it is still absorbing heat. And this heat, to change from one state to another state without changing the temperature, is called latent heat. Clear? Now, quickly let's see. Focus over here. Let's see the phase change diagram. We call this diagram as the phase change diagram. Okay. Now, let us assume that this is the x-axis is our energy and y-axis is our temperature. Clearly, you can see it over here. Look. Now, say substance is here. Okay. You are supplying heat to it. So what will happen? The temperature will increase slowly. So as temperature is increasing, you are supplying a body the temperature, the heat. So as temperature is increasing, that is you are supplying energy, that is heat. Energy is also increasing, thereby temperature is also increasing. But at this point, you can check at this point, the temperature remains constant, but you are giving heat. Heat is increasing, but temperature is constant. You can see that temperature is constant, but heat is increasing. The energy absorption is still there. Why? Because at this point, it is actually changing from solid to liquid, and this part is called to be solid liquid phase, transition state, solid liquid phase, okay, or solid liquid transition phase. Understood? Similarly, when you are supplying heat to liquid, you will find that at certain temperature the liquid will not rise, the temperature will not rise, still you are giving heat, and you will see that that liquid will change to the next state, that is the gaseous state. Okay, similarly you are supplying energy and the temperature remains constant over here. Clear? Now at this point the temperature remains constant, but the energy is increasing. Heat energy which you are supplying is still there, is increasing. So this part, temperature remains constant, but energy remains constantly, it increases, and this phase is known to be liquid gas transition phase. Okay, liquid gas transition phase. So this part is called to be latent heat. The heat which you are supplying at this moment can be called as the latent heat. The heat which you are supplying at this moment can be called as latent heat. Now you already know the thing that solid, when you give heat, it changes to liquid, we call it melting. Liquid, when it changes to gaseous state, when you give heat to it, we call it vaporization. Similarly, the reverse of it, that is gas, comes back to its liquid phase, we call it condensation. The process is called condensation. Similarly, liquid comes back to the solid phase, we call it freezing. Clear? So this is the very important diagram which you have to understand and learn it. Okay? Now let's move to the last topic, that is 5 states of matter. Quickly let's see it. You already know the 3 states, that is solid, liquid and gas. Then what are the 2 more states? The 2 more states are called plasma state. Okay, the 2 more states are called plasma state, and next is Bose-Einstein condensate. Clear? Plasma state and the Bose-Einstein condensate. Plasma state is super excited state. The particles in this state is very much excited, super excited state is called plasma state, whereas BEC, that is Bose-Einstein condensate, in this state the temperature is very low. Okay, the temperature is very low. It is absolute zero, that is minus 273 degrees centigrade. Clear? The temperature over here is very low, whereas the temperature over here is very high. Clear? You can term this as a super unexcited state, and this can be termed as super excited state. Clear? The example of plasma you can take down, that is sun, is a fine example of plasma. Okay, the next example you can take down is fluorescent bulb. Okay, whereas BEC, that is Bose-Einstein condensate, the fine example is semiconductor, or you can say superconductor. Superconductor. This is an example of BEC, Bose-Einstein condensate. Okay, so now we have come to the end of this chapter. Few topics are left out. We'll discuss in some other videos. Okay, so let's end today's class. Thank you very much.